All right, I'm going to go over some problems from um, the sections for 12.3 and 12.4, days 1 and 2. Okay, just to emphasize an inscribed angle like this here, angle ABC is an inscribed angle, right? The angle is inside the circle. Okay, and every inscribed angle has an intercepted arc, right? And so at point A to point C, right, this arc is the result of the cutoff of this inscribed angle, okay? And so the measure of angle B, the inscribed angle, is always half of the measure of the intercepted arc, okay? And so if the arc was 100 degrees, then the angle would be 50 degrees, okay? And vice versa. If you know the inscribed angle, then the intercepted arc is going to be twice as much, okay? And so let me go over some problems here. Here in number 8, some of these I kind of already started a little bit. So in number 8, you're asked to find A and B, right? A is an intercepted arc, PT, and what's the inscribed angle? It's angle B, right here, angle PRS. So once we figure out angle B, maybe we can figure out A, but if you also look what I highlighted, right? Angle PQT is 60 degrees. This is an inscribed angle, and look, it shares an intercepted arc, right? So PT is going to be twice as much as 60, and so therefore angle or intercepted arc A is going to be 120 degrees, okay? So inscribed angle, this is the intercepted arc, this is 120 degrees, okay? Um, I lied. I apologize. The inscribed angle B here, it looks like the intercepted arc is actually PTS, right? So PTS is going to be 150, right? 120 plus 30. And so angle B is going to be half of 150, which is 75 degrees, right? And number 10, I started this for you here. There's a lot that's confusing possibly, right? And so I'm going to try to break this down. Intercepted arc A, right? From this point to this point, this is the inscribed angle here. It's 39 degrees, right? So A is going to be twice as much as that, so that's 78 degrees, okay? If you take a look at angle B, I know it's a little bit off, but angle B is right here, this angle, okay? And look at its intercepted arc, right? Maybe I'll make this one green, okay? So here's the inscribed angle, and this is the intercepted arc right here, from here to here, okay? Because this is the angle that we're looking at right here. And so take a look. Well, it goes through the center, so that means this is 180 degrees, right? Okay, so that must mean that B is going to be 90 degrees, all right, half of that, okay? For angle C, here's the inscribed angle right here, okay? And here's the intercepted arc out here, okay? Well, if this is 50 degrees, and we already know it's a semicircle, then this intercepted arc must be 130, right? And so C is going to be half of the 130, so that's going to be 65 degrees. Okay. For number 17, I also started this one. D, I started over here. Again, it's a semicircle because it runs through the center, right? You know that's the diameter, so D is going to be 180 minus 110, all right? So D is going to be 70 degrees, right? 70 degrees. E, this inscribed angle here, right? And here's the intercepted arc at 76, right? So E is half of 76, So that's going to be, I think it's 38, right? 38 degrees. Okay, so that's 38 degrees, right? And then what else do we know? Well, let's take a look here. Angle A, this inscribed angle, right? This angle right here, okay? The intercepted arc is right here, over here, right? So we figure that out, right? That's 70 degrees. So then A is going to be half of 70, right? So A is going to be 35 degrees, okay? If you take a look at B and A together, right? This is an inscribed angle of the semicircle. So this must be 90 degrees, right? And so A plus B must be 90. And if we figured out A is 35, then B is going to be 90 minus 35, right? So B is 55 degrees. Okay. And then lastly, angle C, right? Angle C comes from the theorem that, right, this angle right here, okay? Here's the intercepted arc, right here. Well, that's going to be, so if we can figure out this arc, then the angle is going to be half that, right? And so the arc itself is going to be 360 minus 110 minus 70 minus 76, right? And then once you figure out that arc, angle C is going to be half of that amount, all right? For number 18, all right, for this problem, angle B here, okay, angle B, this is the inscribed angle, and here's the intercepted arc, 64, right? So B is going to be half of that, that's going to be 32, okay? And again, if you look at A and B together, that's going to be 90 degrees because the semicircle is the intercepted arc, okay? And so if B is 32, then A is going to be 90 minus 32, and so A is equal to 58. Okay. And again, C, right, is this angle here, and we're looking at, well, C is going to be half of the intercepted arc right here. So if we can figure out that arc, C is going to be half of that, all right? Okay, so, well, we already know this is 102, this is 180, right? So this arc, right, let me do this. That arc is going to be 360 minus 180 minus 102. And again, whatever that is, C is going to be half of that, all right? Let's take a look at this one. Okay, this one, they're actually maybe not trying to trick you, but it's actually a lot more easier than it appears, okay? So we actually don't need the 60 and the 70, all right? This arc here, sorry for my terrible highlighting here, okay? That's 180, right? Because it's a semicircle. And then we have this intercepted arc, right? Okay. And 53 degrees is this angle right here, all right? So where does the 53 come from? Well, the theorem says this outer angle, right, 53, is you're going to take the bigger arc minus the smaller arc and take half of it. So that's going to be 180 minus y divided by 2 ends up equaling 53 degrees. Okay, so you actually don't need the 60 and the 70, right? You just need to know this is 180, right? That's the bigger arc because it's the endpoint of the angle here, right? And then you have this other intercepted arc right here, okay? Then for this one, okay, for this one, you know this is 180, right? So this actually is a diameter, right? It goes through the center of the circle, which means this angle here, y, is an inscribed angle, and so y is going to be half of that 180. It's an inscribed angle, and so y is 90 degrees. Okay. Well, look, now you've got a triangle, right? Triangle adds up to 180. If this is 90 and this is 46, you can figure out what z is, right? Z ends up being, I believe, 44. Okay, so that's 44. Well, take a look at angle Z, right? This inscribed angle, look at where the endpoints are, right? You've got this intercepted arc right here. So this arc is going to be twice as much as Z, which was 44. So this arc here is 88, right? Now we need that 88 because here is the major arc, 180, that's intercepted. Here's the minor arc, the 88 that we need, right? And so x is going to equal 180 minus 88 divided by 2. All right. Here's 20. All right. 232 is all of this, right? This whole thing, right? Which means the leftover is going to be 360 minus 232, right? 360 minus 232, which is actually 128, right? So this is 128 right here, okay? So we need that because then z is going to be 232 minus 128, right? The bigger arc minus the smaller arc divided by 2, all right? And that turns out to be 52 degrees, I believe. Okay, so z is 52. All right. Now, here's where you gotta try to remember these theorems. Okay. Let me erase that real quick. So that's 52. Okay. Now we learned, all right, that if you have an outside point and this is tangent over here, right? Okay, if they're tangent, then these must be congruent. Okay, if you have a common point outside the circle, going to a tangent point here and one over here, then these are actually congruent. Now, if you notice then, now you've got an isosceles triangle, which means, actually, remember the theorem from first semester? If the sides are congruent, then the base angles are congruent. So x and y are actually the same measure, right? And so we've got x and y is going to be 180 minus 52, right? And then divide that by 2, and that'll give you x and y. Okay, I believe it's 64. And the last one I'm going to go over here, all right? Lot to cover. Z, I'm going to start with Z because Z is an inscribed angle and 96 is the intercepted arc. So Z is going to be half of 96, right? So that's 48, okay? Then for the Y, right, this angle inside the circle, Y is going to be the major arc, the major intercepted arc, 96, plus the minor arc, 24, and then half of that, okay? Whatever that is, all right? And then for X, we're going to use the same major and minor. 96 minus 24 this time, divided by 2. All right, and so, like I said, a lot of visual things here, okay? If you have any questions, please shoot me an email. If you want to see some of the other ones that I didn't do, please shoot me an email or come join us. Or actually, we're gonna do the Zoom meeting. All right, so hopefully we'll see you then.